ఫ్రెండ్స్, ఈ వీడియోలో మనం రిజిస్టర్ ట్రాన్స్ఫర్ లాంగ్వేజ్ అండ్ మైక్రో ఆపరేషన్స్ ఇన్ COA కంప్యూటర్ ఆర్గనైజేషన్ అండ్ ఆర్కిటెక్చర్, కంప్యూటర్ ఆర్గనైజేషన్ అండ్ కంప్యూటర్ ఆర్కిటెక్చర్ కోర్స్ రిలేటెడ్ సబ్జెక్ట్ ఇది. ఈ వీడియోలో మనం రిజిస్టర్ ట్రాన్స్ఫర్ లాంగ్వేజ్ గురించి డీటెయిల్డ్గా చూద్దాం. Registers are smallest memory part in processor. A register is a collection of flip-flops where each flip-flop stores one bit information. If you have seen last class, I have said about bit. One binary digit store అయ్యే ప్లేస్ని మనం బిట్ అంటామని చెప్తున్నాను. సో దట్ బిట్ ఈజ్ ఆల్సో కాల్డ్ యాజ్ ఫ్లిప్-ఫ్లాప్. ఈ ఫ్లిప్ ఫ్లాప్ అంటే ఏంటి అంటే ద స్పేస్ విచ్ ఈజ్ రిక్వైర్డ్ టు స్టోర్ ఏ 0 or 1. ఇలాంటి ఫ్లిప్ ఫ్లాప్స్ అన్నీ కలిసి అంటే ద కలెక్షన్ ఆఫ్ ఫ్లిప్ ఫ్లాప్స్ ఈజ్ కాల్డ్ ఏ రిజిస్టర్. సో ఈ రిజిస్టర్లో మనకు 4-bit రిజిస్టర్ అని, 8-bit రిజిస్టర్ అని, 16-bit రిజిస్టర్ అని, 32-bit రిజిస్టర్ అని, 64-bit రిజిస్టర్ అని ఉంటాయి. సో సపోజ్ మనం కంప్యూటర్లో కూడా 32-bit రిజిస్టర్ అంటాం, 64-bit రిజిస్టర్ అంటాం. సో దట్ ఈస్ ద నెంబర్ ఆఫ్ ఫ్లిప్ ఫ్లాప్స్, ద కలెక్షన్ ఆఫ్ ఫ్లిప్ ఫ్లాప్స్. ఒక రిజిస్టర్లో 8 ఫ్లిప్ ఫ్లాప్స్ ఉంటే దాన్ని 8-bit రిజిస్టర్ అంటాం. ఒక రిజిస్టర్ కెపాసిటీ 4 ఫ్లిప్ ఫ్లాప్స్ అంటే 4 zeros or 1sని స్టోర్ చేసుకున్నట్లయితే దాన్ని 4-bit రిజిస్టర్ అని అంటాం. సో రిజిస్టర్ ఈజ్ a smallest memory part of our processor or computer, which is collection of flip-flops, and each flip-flop stores one bit, that is 0 or 1. We have 4-bit register, 8-bit register, 32-bit register, 64-bit register, like this. Okay, so here you can see the black diagram of register. So in future in this subject we are going to see so many diagrams and so many hardware implementations. In that hardware implementations we are going to represent the register within the rectangle with the symbol R. Okay, so register R we will see like this, I mean represent like this. Or if you want to show individual bits in register, we will represent like this. This is an 8-bit register, so 0, 1, 2, like this we will represent the bit numbers. Okay, or if you want to show with the numbering of the register bits of the register, you will do like this, 0 to 15 means it is a 16-bit register. Okay, or you can represent like this also. We are going to divide the register into 2 parts. So the first part is called PCL and the second part is called PCH. What is meant by PCL? So lower order byte. Okay, what is PCH? Higher order byte. What is meant by byte? 8 bits. So 16 bits are divided into 8 bits and 8 bits. It is called PCL and another one is called PCH. What is meant by PCH? Lower order byte, and this is called higher order byte, divided into 2 parts. Okay, this is how we are going to represent the register in our hardware implementations. Next, so very important topic, very important topic, register transfer. So before going to register transfer, we should know micro operation definition. So what is micro operation? The basic operations which are performed on the register data. So the basic operations executed on data stored in registers are called micro operations. In simple word, it is an operation which is performed on the contents of register. So register లో ఉన్న డేటా మీద నేను పర్ఫామ్ చేసే ఆపరేషన్స్ ని ఏమంటున్నాం? మైక్రో ఆపరేషన్స్ అంటున్నాం. సో ద మైక్రో ఆపరేషన్స్ ఆర్ ఆపరేషన్స్ విచ్ ఆర్ పర్ఫార్మ్డ్ ఆన్ register content data. So for example, we can take shift, count, clear, load, like this operations. These are the operations which we perform on registered data, so it is called as micro operations. Next, register transfer. You know that what is transferring. Transferring means here data. Transferring data from one register to another register is called register transfer. So to perform operations or to process programs or to execute programs, we have to transfer data from one place to another place. So to transfer the data from one place to another place, we use the register transfer. So here I have the content in R1 and I am transferring that content into R2. Then I will represent that transferring R1 into R2 like this. This is the representation of transferring the R1 data into R2. Okay. So this arrow symbol is there now. So this arrow symbol is called replacement operator. Whatever the symbol we are showing, from which register to which register we are transferring, that symbol, that arrow symbol is called as replacement operator. Okay. So this above instruction which I have given as an example states that we are sending the data R1 to R2. I mean, we are transferring the data R1 to R2. Whatever the arrow mark is represented, that side data is going. That is the receiving register. Okay. Here, if P equal to 1, then R1 replaces R2. So what I am saying, P is the control signal. So which is generated by control unit. Control unit generates the control signal, means it is giving the permissions to transfer data. Okay. If it is 0 means it is not giving permission to transfer. If it is 1 means it is giving the permission to transfer. So here P equal to 1 means it is giving the permission to transfer the data from R1 to R2. So this is represented like this. This is called control function, control instruction. So that is P colon R1 replacement operator R2. R1 replaces R2. Sorry, R2 replaces R1. So R2 ni R1 data toni replace chestunnam, replacement operator. Okay. So this is called control function. Here you can see block diagram of hardware circuit. It is also called as conditional transfer. So here we have a control unit. So that control unit generates the control signal. So as I said in previous example, P equal to 1. P equal to 1 means it loads the data into R2. Okay. Where is the data now means it is in R1. In R1 we contain some n bits that will be transferred into R2. If the control signal gives the positive signal, means 1 signal. Okay. If it is 0, it won't load. Okay. If it is 1 only, it will load. If control signal is 1, if control signal P is 1, then only R1 bits, whatever the bits R1 having, that will be loaded into R2 at some clock pulse time. This clock pulse time will show at what time these n bits should transfer or should load into R2. Okay. This is simple block diagram or hardware circuit of a conditional transfer. Okay. Timing diagram. So timing diagram shows that transfer is successfully happened or not, and at what time it is happened. So here we have a clock pulse and load generator. So this clock pulse having like this symbol, means if it is going the upside means the operation is ready to start. So if it is going downside means the operation is completed and it is in ideal state. So if there is any 1 means operation has to start. If there is any 0 means there is no operation. Okay, so here load operation is 0. Why? Because here we have 0 in clock pulse, and here 1 means it can start its operation and it will execute, and after completing it will come to ideal place. So this is P control signal transfer successfully completed at this place. After that it will be ideal again. So like this timing and control diagram will be shown. So in future classes we will discuss in deeply about this. Okay, so here in last diagram, in last example, we have used a few symbols. What are that symbols, why we use that, all we will discuss here. Letters and numbers, so denotes a register. So R1, R2, PC, IR, MAR, MDR, MBR, all this represents the register names. So R1 is a register, R2 is a register, PC is a register. So in future we are going to use all these. Okay, so next parenthesis we have used, denotes part of register. So we have used PC like PC L means this is lower byte part of register. PCH means higher byte part of register. So arrow we have used, it denotes transfer information. We call it replacement operation. Okay, and we have used commas. Commas are used to separate two micro operations or two registers like this. Okay, so next, register transfer language. It is a system for expressing symbolic form of the micro operation sequences among the registers of digital module. సో ఒక డిజిటల్ మాడ్యూల్లో మైక్రో ఆపరేషన్స్ని సింబాలిక్గా మనం చూపించాలి అంటే we will use register transfer language. It is very close to assembly level language and it is very easy to understand. Simply it is a symbolic representation of micro operations. సో మైక్రో ఆపరేషన్స్ ఏవైతే ఉన్నాయో అవి ఏ ఆర్డర్లో ఉండాలి, ఏ సీక్వెన్స్లో నడుస్తున్నాయని చెప్పేది register transfer language. So for example, here I have given an example, R0 arrow mark and R0 plus R1 means here we are going to do the contents of R0 and the contents of R1 addition, and we are storing it into R0 again. Okay, we are transferring the data into R0 again. Here we are transferring the data of R2 into R1, replacing the data of R2 into R1. Okay, so here we are going to learn list of common registers used in digital computers. Accumulator, first one is accumulator. We are going to use widely this register in our next classes. It will be represented with AC, and accumulator stores 16 bits. So accumulator capacity is 16 bit. It is a processor register and it is used to store intermediate values of a process. అంటే మనం ఎగ్జిక్యూట్ చేసేటప్పుడు ఏమైనా ఇంటర్మీడియట్ వాల్యూస్, రిజల్ట్స్ ఇవన్నీ వచ్చినప్పుడు కూడా మనం అవన్నీ కూడా అక్యుములేటర్లోనే యూజ్ చేస్తాము, ఐ మీన్ స్టోర్ చేస్తాము. సెకండ్ వన్ ఈజ్ ప్రోగ్రామ్ కౌంటర్. సో ప్రోగ్రామ్ కౌంటర్ని మనం పీసీతో రిప్రజెంట్ చేస్తాము. ఇట్ విల్ బి 12 bits, a register with 12 bits, that is program counter. It will be represented with PC and it stores the address of the instruction. So PC లో program counter లో మనం అడ్రస్ ని స్టోర్ చేస్తాము. ఓకే, ఇట్ విల్ బి 12 bits అంటే 2 power n means 2 power 12 means 2 power 12 means 4096. Okay, 4096 addresses we can store using program counter. I will explain this in deeply in next classes. Address register. So name itself saying that address register means which is used to store address of any register or any data. It is also 12 bits. And second one is data register. After address register, next one is data register. It is 16 bit. It is a general purpose register which stores data during calculations. So while we are doing execution of any program, we have to store some data. To store that data, we are going to use data register. Next, instruction register. So instruction register name itself saying that we can store current executing instruction. Whatever the instruction we are executing now, that will be stored in instruction register. It will be 16-bit and the symbol is IR. Next, temporary register, TR for temporary register. It will be 16 bits and it holds that temporary data. Whatever the data we want temporarily, we can store it in temporary register. Name itself saying that temporary data means temporary register. Next register is input register. It is called INTR. It is 8 bits and it carries the input characters into processor. And output register, it is represented with OUTR and it is 8 bits. It carries output characters from processor to output. Next, MBR. What is meant by MBR? Memory buffer register. So memory buffer register is used to store the data or memory commands used to write on the disk. మనం మ్యాగ్నెటిక్ డిస్క్లో కానీ హార్డ్ డిస్క్లో కానీ రాయాల్సిన డేటాని రిప్రజెంట్ చేయడానికి వి యూజ్ మెమొరీ బఫర్ రిజిస్టర్. నెక్స్ట్ వన్ ఈజ్ మెమొరీ అడ్రస్ రిజిస్టర్, MAR. అడ్రస్ లొకేషన్ ఆఫ్ మెమొరీ ఈజ్ స్టోర్డ్ ఇన్ దిస్ రిజిస్టర్. ఇట్ విల్ బి 12 bits. Last one, flag register. So FR it will be represented with, it will be 1 byte or 2 bytes. Used to indicate particular condition. The size is 1 or 2 bytes. Zero flag, carry flag, priority flag, sign flag. Like this, we have so many flags. We will discuss in next class. This is all about the general registers which we use in our COA.